project ID. This is the project I want to use. And I execute the cell. Okay, maybe I'll need to authorize the notebook to run on my behalf. Okay, the next step. And here, so you see, I need to allow, because the notebook is coming from a Google repo on GitHub. So yeah, always pay attention and confirm or not. Okay, you need to authorize access to Google Drive because you can save this in your Google Drive. And that's it. I'm ready to get started. And as a confirmation, so we're using the Agent Platform API. So that's the AI platform on Google Cloud. And this is my project, and we're using a global location. So it will distribute, it will load balance the request a bit everywhere, depending on the load. Okay, let me switch maybe to a different view. So it's going to be maybe more visible for you. Okay, we will use two different types of data to get started. Plain text, so we'll take classical books. They are a good source, they're free. And we'll also use PDF files, okay? But keep in mind, Gemini is multimodal. So whenever you do something with one medium, so with text, for instance, and if it works, it will also work with other medias. Okay. So for instance, if my use case works with text and PDFs, and I want to do something similar with images, audio, or videos, then I can do that as well. I can change the inputs. Also, regarding languages, so I'm French. I'm very likely you all have different native languages for those who are attending right now. And so Gemini supports over 100 different languages. So virtually all the languages that we use, not all of them, but virtually almost all of the languages that you speak. And so what we're going to do is we're going to use English prompts, but it can work in your own native language. And if it works in English, also you can switch, you can provide any document in any language, and you can also generate the outputs in these other languages. Okay, so it's very flexible. Of course, we tend to work in English because we're used to, and it's a common language for most of us. But you can work in your own native language, and you will see I'll be using some French books. Okay, so it doesn't make a difference. Okay, so now let me define a few data sources. As you can see, from Project Gutenberg, I will use Les Misérables, Count of Monte Cristo, Thérèse Raquin, a French book in a French version, and the whole of the Count of Monte Cristo, so the 4 volumes. Okay. And also we'll have a look at a legal agreement. Okay, so a PDF document. Let me check. Yeah, so the data helpers are defined. So it's interesting. So it's a new problem that we try to solve. So it's interesting to get started small, right? So use the smallest model and use a small input, okay, to develop some intuition. As of today, Gemini 3.1 Flashlight is the smallest Gemini model and the fastest one. And you can do a lot with it. Okay, so it's pretty, and it's super, super cheap. So it's very nice to get started with this. And if it works with a flashlight, then you'll be able to do a lot and maybe just increase with larger models when needed only. Okay. We will, so it's a data extraction use case. So we will use some parameters to minimize randomness. So it's a very specific, usually you don't do that, but we have a very specific use case. So now let's define some helpers, okay, some functions, some data structures. So those are the models that we can use today in this lab. By default, we will use a 3.1 flashlight, but in some other cases, we will upgrade to 3.5 flash, okay? And you can use others as well. That's basically the gist of the function we will use everywhere. We want to generate content. with a prompt, with or without sources, okay, and with some parameters. And you can see this is it. We have some network management here in case of error, but we call generate content, and that's it. Okay, so those are some functions just to display what's happening. So the next phase now is to get started, to try to solve our problem with prototyping. So again, prototyping helps you develop intuition and know whether you're being able to solve the problem or not, if it looks good, or if you should look for a different solution. So again, let's start small. So for this, we can use, for instance, a small text. So here it's a made up text. So Henry Jones, if you guess, this is Indiana Jones. But so I'm using some real facts, but also some made up facts, or also some facts coming from books and not from the movie. And so Short Round is in one movie, William Smith, it's just made up. And so here with this small, it's like a unit test. I want to test Gemini to see if it's able to understand everything. So you can see, so Sophie is the daughter of Henry Jones. She shares this last name. So you see, I'm having some levels of indirection to see whether Gemini understands everything. Okay, so let's get started with prototyping. And with this first prompt, using only the input data. So we don't want Gemini to take data from Indiana Jones movies and so on. List all persons and animals mentioned. And as you can see, let me make this a bit bigger. Yeah. We get persons and animals. Henry Jones, Sophie Jones, William Smith, short rounds, short round, sorry, Bo, so a dog, a made up dog. And you can see the input text is small and the output is small as well. So it's looking good, right? Gemini can really understand the document. So let's move to the next stage. Try to extract the relationships between those characters at the same time. Okay, so it's almost the same prompt, but here we are going to ask, okay, list all persons and animals, but also how they relate to each other. Okay, so let's run this. And as you can see, Gemini Flashlight is really super fast. In seconds, you have the answers, like in 2 seconds, 2 seconds here. So here we do get the persons and the animals, but we also get the relationships between them. So it's good. It's really looking good. Gemini has a real understanding of the information and also how every entity, so that's how we are going to call the main characters, the main entities we want to extract, how they relate to each other. Okay. So looking good. Before we go further, so it's a new domain. So we are not specialists in knowledge graphs. And so it's always interesting to ask the model you're using what it knows about it. Because as you know, LLMs have been trained on massive data sets. And so if you ask them about some topic, the model will tell you what it knows. And it's pretty nice because it will help you craft better prompts. And so here, what is the terminology used when building a knowledge graph? Please provide an example and so on. You can see that we get the core terminology, like we should be speaking about entities, about nodes, maybe relationships, or edges, or links, and so on, properties, attributes. And as you can see, we get a nice example. Okay, so yeah, nodes, IDs, labels, properties. So it gives us a starting point. Okay. And so for the next step, we want to start managing data. Okay, and also we want to be able to move from natural language to something that is structured and that we can use in production with code. And so for this, you can really see our problem like a database with two tables. So this is an example from our text. So for instance, in our text, we would like to extract two entities, Henry Jones Jr., Henry Jones Sr. They are both persons, okay? And also relationships. And one way to express relationships is like this with two tables in a database. And so ID 0, ID 1, and ID 0 is the child of ID 1. Does it work? Yes. Gemini is able to generate dynamical identifiers like this. And so this is something I call tabular extraction. And as you'll see, it works nicely. And so let's extract the entities now. So we are getting more and more structured. So we can provide the data. Oh, it's already finished in 1 second. So as you can see, to move forward, we can define some data, just provide a data schema. So describe what an entity is. It has an ID, it has a name, a label, provide some details. For instance, we only want to extract persons and animals. And the instructions are pretty short. Extract every distinct entity from the input data, matching an allowed label. Okay. And so the main format for the industry today is generalized okay, child of, friend of, pet of, parent of, and friend of. Okay. So it's still looking good. We are moving towards production with something that will work in a reliable way in production. So for the industry today, the typical next step would be to move to be full JSON and to tell the model, so here to tell Gemini, please only output JSON. And for this in Python, you could, for instance, provide Python classes, and it would automatically build a JSON from this JSON schema and only provide you data for this schema. But for this use case, we can explore something better because we are actually extracting two tables, okay? And so really what we want is just table outputs, okay? And so one nice way to represent this is to have two code blocks like this. So a TSV is a tab separated values table. And so typically what we want is a first table for the entities with an ID, a name, and a label. And here we're using a lot less tokens, as you will see. And then we want at the same time, right after, a second table for the relationships with the source ID, a tabulation, of course. So here it's just symbolized, a link and a target ID. Okay. So quickly, so you understand, is it worth doing this? We can actually compare what a JSON would give compared to a TSV. So in 324 characters, we only represent 1/3 of the JSON. You see, we have to stop here. Even if we compact the JSON here, we can only represent half of the JSON. You see, it will stop here. Actually, it's we don't have the relationships. It has to stop there. But in this number of characters, we can represent 100% of the tables. So in terms of characters, it's looking good. And in terms of tokens, it should be similar. So let's compare that. So it's going to send request to Gemini to ask how many tokens we would need. And as you can see here, if we compare compact JSON to TSV, it's a 35% gain. And for formatted JSON, so what everybody uses, it's almost 70%. So in short, you can save between 30 to 70% of tokens, which is a lot, really a lot. And why is it nice to do that? Because every request will be a lot faster. And if it's faster, it also means that it's going to be cheaper because you will use less tokens. Okay, so the both are related. So let's move on and finalize our code. Okay, an interesting way for this is to have a prompt template. So here we know we have a data schema for our different documents. We have instructions and we have an output format. Okay, so let's define this. Okay. And now, as you can see, I will skip this. I will let you have a look, but you can have classes, Python classes, or in your favorite language, an entity, a relationship, a knowledge graph is just a list of entities and relationships. Okay, and you can see here our output formats. Okay, so this is exactly what we define. And then we can define additional functions to manage this and automatically generate a knowledge graph. Okay. So now let's move towards analyzing books. Okay, so for a book, we want, for instance, to extract persons, animals, organizations. What's nice now, we have a structure, we can maintain the code, we can add more and more fields or more and more labels, types. And so this is something we can maintain in a nice way. Okay, and this is, so this is the data schema we want. So it's similar to what we had before, but we need to be a bit more precise because we want to do a lot more on books. And those are our instructions with a bit more details. Okay, I will save time and move forward. Okay, so let's have a look at the prompt that we will use, of course. So this is our input data. This is our user prompt with the data schema, the instructions, and the output format. So it's looking good, right? Always pay attention to what you send to the whole request that you send to Gemini. And now let's try to build our first real knowledge graph. Okay, so we got 245 output tokens, and this is the response that we got. It's really looking good. And if we build a knowledge graph from this, those are the entities in Python here and the relationships that you can see. Okay. So still looking good, still progressing. I'll skip this one, but the next step, if you want to be able to manipulate the data, is to use something close to your data. And a network graph is something ideal for this. It will just use the Python data and process this in a nice structure. So here from our knowledge graph, we have actually a directed graph. So there are nodes with edges, directed edges between the nodes. And here in our small text, we have 8 nodes and 16 edges. Okay, you can see Sophie Jones, William Smith, and so on. Also, something we can do almost systematically is have something to visualize the data. Okay, so here we are defining some visualization helpers, and let's test. Yeah, so I hope you can see this. So from our small text, this is the first knowledge graph we extracted. And so Henry Jones is the friend of Short Round. So they met in a taxi initially and so on, but eventually adopted Short Round. So this is what we have here in two relationships. Sophie Jones is also the daughter of Henry Jones, biological daughter, and so on and so on. William Smith is a friend of Sophie. He has a dog named Bo. So you can see Bo is a pet of William Smith. So all the all the relationships have been nicely extracted. But it's a small text, okay? So now let's try to see if we completed our challenge. Let's define a meta function, analyze book. In this function, we will have the book analysis data schema that we define, the instructions, and so it's just a wrapper to show the knowledge graph. Okay, let me execute this. Okay, and let's have a look at what we can do on books. Okay, to save time, I have a backup. Okay, I will show you here because we have a couple of minutes more. Okay, so let's move here. Yeah, for instance, there's one book that will need 1 minute of processing. So let's move to snapshot mode. And so here on Terra's Raquin, Terra's Raquin is a real book with a few characters only. We get a super nice extraction. It's small, but the book is not small, but actually there are just a few relationships. And here you can see a love triangle already between Thérèse, Camille, and Laurent. And you can see also that Laurent is going to murder Camille. What a bad person. If you analyze Les Misérables, which is a big book of 800,000 tokens, you get a super nice extraction. You can see Jean Valjean here. You can see Cosette and Fantine. You can see all the family links, all the friendship links, what's going to happen with the employer of, and so on. And you can move on. So there are some details for each example. So if we analyze the first volume of Monte Cristo, we get this. So we get the main protagonist, Edmond Dantes. We know that he is fiancé with Mercedes, okay? But we also know that Fernand is a cousin of her, and they are rivals. So we kind of see a first glimpse of a love triangle, and things are going to get messy. And if we analyze the 4 volumes all at once, so that's again over 800,000 tokens. Now we see all the complexity of the book. Edmond Dantes, which is a real person, has actually an alias, Le Comte de Monte Cristo, the Count of Monte Cristo, sorry, and other identities like Lord Wilmore and so on. And so you see the real complexity of the book because it's like a chess match. They're using different identities, and likewise for Fernand was the antagonist. As you can see, Mercedes got married to not to Edmond Dantes, although she was fiancée to him. Okay, engaged to him. Okay. So you can see the challenge is really completed for books. You can do a lot more, but just in one request, it's pretty amazing. Just to give you some ideas, because maybe you don't want to analyze books, how you can generalize this to something else. And for example, an agreement, a legal agreement. So let me, let me move to this. So for example, here we have a legal agreement of, almost 100 pages. A legal agreement is like madness because it's a very dense document, and you need a lot of time to go through it. There's in every sentence there's like a few pieces of information, and so this is an example of what you can do with a semi-open prompt. You can tell, okay, those are the entities that I want to extract. And then you can have open instructions for the relationships. So here, for instance, we can focus on the legal obligations. and this is what we get. So here, 1,000 tokens. So it's not that big, but those are the main obligations. And likewise, if you want to focus on something else, just adapt the data schema and the instructions. And here, this is an example of a prompt where we want to extract the structure of the document. And so it can get a lot bigger, okay? Yeah, and that's it for the gist of the demo. Maybe it will give you ideas to, I don't know, extrapolate this and use this in a different domain for different types of documents and so on. But it gives you the basis of what you can do and how far you can go. And there are additional details in the lab. I'm going to stop here and to give you murder. Okay, to give you some time for the Q&A. And now I'm handing it over to Shiv. Thanks a lot. Stop sharing.
Thanks, Laurent. That was amazing. Made me want to start reading some of those books as well and learning more about those characters. So yeah, like Laurent said, lots of use cases for that I'm sure many of you can think about in your day-to-day jobs. But yeah, we had a bunch of Q&As that'd be great to go through. So I'll just start picking them up, Laurent, and maybe you can answer them. So we have one here from Ramisa, which is, hey Laurent, the tabular extraction approach looks like the schema table from entity relationship diagrams. Are they identical? You've got on mute. 1 second, Laurent. You're on mute.
Yeah, sorry. Yeah, to answer your question, I don't know what you mean by ER. But most likely, yeah, I did not copy this from something else. I just tried to start from scratch. But the principles are pretty universal. So yeah, I knew that a knowledge graph has entities and relationships. But if you have a look at the code lab, you will, and especially when we ask Gemini, okay, give us an example of what you can do. Everything you've seen here is very simple, but it can get a lot more complex or a lot richer. Like for an entity, you can have lots of different properties. So yeah, to answer your question, yeah, I just showed a proof of concept of what you can do in one request with a simple data schema. But then it's up to you to use that how you see it fit, and especially yeah, there are a lot more advanced ways to build knowledge graphs. It really depends what data you want in the entities and what the relationships, what are the relationships that you want to extract. Yeah, so I hope it answered your question.
Great. We have a couple of questions from Colin. So I'll start with the first one, which is, how different would it be doing this on BigQuery Graph that was just introduced to GCP?
So I'm not an expert with BigQuery Graph, but it's like an extension. So in this proof of concept, what we've done is extract data, and this data is structured. So typically, the next step for a fully professional solution is to put this data in a database. And so for this, yes, you can use BigQuery Graph. You can use other professional solutions like Neo4j and more. And again, I'm not an expert in knowledge graphs, but let me share again my window. So for example, this last example, it has how many? It has 800 relationships and almost 600 nodes. So with this proof of concept, of course, it's just just a picture. Okay, if you use a professional tool like BigQuery Graph or Neo4j or others, then you will be able to zoom in this to explore, to see the properties of every node and so on. And also, why not? You could also modify the data directly. And so what BigQuery Graph will bring you is what we've done here on up to 1 million tokens. Actually, you can put all of your different knowledge graphs, the ones that have been generated. You can analyze the data. You can create additional graphs directly in BigQuery. So, for instance, in the book analysis, if we wanted to classify the data, to analyze the links, the relationships that are family links, the relationships that are, I don't know, social links, maybe analyze interactions and so on, you could actually build additional metadata above this, classify the entities, classify the relationships, make statistics. So what BigQuery Graph brings here is the capacity to analyze all of this all at once, independently from the size of the data. And for example, you could have petabytes of data in BigQuery Graph. So here, Gemini will let you extract information and build knowledge graphs. But what we've done here is you have a bridge between BigQuery and Gemini. So you can also have in BigQuery, if you know how to build the queries, you can actually directly use Gemini in BigQuery. This is not something I have experience with, but I know it's possible, and I'm sure this is also something you could do directly. But just
Yeah,
to close on this question, BigQuery Graph will let you explore all of this, manage thousands, dozens of thousands, hundreds, millions of nodes and relationships. And this is not something that Gemini can handle today because it's limited to 1 million tokens. But 1 million tokens is enough for War and Peace, Les Miserables, The Count of Monte Cristo. BigQuery is like the ultimate solution to manage, for instance, all the books you have in your library, all the documents you have in your enterprise. I hope it was clear.
yeah. So you can just go bigger and deeper with BigQuery, and to Lauren's point, you could still use Gemini to help you ask questions as well, which is one of the great things with Gemini built into BigQuery. The second question from Colin was why TSV and not CSV, and how
Yeah,
does it compare with
yeah.
Tune?
So CSV, first of all, CSV is not a standard. There are lots of variations of CSVs. So, and also CSV. So, for instance, you can use commas, you can use semicolons, and so on and so on. You can use quotes. And actually, if you think about it, TSV, like using a tab separator, is like the most optimized way to represent a table. It works because we don't have tabulations in our data. And so we don't need double quotes or any additional separators. And it's also a tabulation is one token, a line break is one token. Yeah, so this is what, yeah, so yeah, this is why TSV is perfect here. It's like, I think it's the most optimal way to represent tables. And the rest of your question is how does it compare with Tune? So Tune actually, so I put the link in the lab. So Tune is a new format trying to solve the issue with JSON. And Tune is a mix between CSV and YAML. And so Tune would work. You can generate Tune data, Tune formatted data with Gemini. But Tune, again, it's a big formatting structure. And so Tune is not optimized. It's better optimized than JSON. But Tune with YAML, with indentations and so on, will actually compare, will consume a bit more tokens than the TSV. So it's really up to you. If you want to always use JSON, always use Tune in your solution, just go for it. But here in this proof of concept, I just wanted to show that the TSV structure, I think, is like the, the optimal one. You can go not go smaller than this. And it lets you have also another way, a better way to minimize tokens would be to have fields without meaning, like source ID, target ID, link, label. When you want to save on tokens, you try to minimize the length of your fields, your data fields, especially with JSON. So here with the TSV and with Tune as well, it lets you have a really nice name for your data fields. And so, yeah, so and likewise also the LLMs are more confident with explicit names because they provide meaning, they provide a semantic.
Great.
So yeah.
Yeah, hopefully that answers your question there. The next question is there a way to store the knowledge graph, in brackets, create once somewhere and then reuse it later by the team or by other people?
Yeah. Typically, let me show you back the data of what we've extracted. Um, okay, here. If you start slideshow. So as you can see here, we have two tables. And typically, this is something you can store, as we said before, in a database. So any graph database, Neo4j, BigQuery, any NoSQL database, or you can also represent this in a SQL database. As you can see, we have proper columns, proper fields, ID, name, label, source ID, link. So those can be relational data tables in a traditional database. It can be in a NoSQL database as well. Can be in a graph database. So it's really up to you to store this information as you prefer, depending on what you have in your team or what you use as a developer, the tools you use. I hope it answered your question.
And then we've got I'll group a couple of questions because we've got a few questions around formats effectively. So can you also do this with PDF format? Or what other formats might you be able to do this kind of work with?
Yeah, I'm sorry, it was a big of a rush at the end to show you as much as possible. So what we've done in this demo is actually use text files. So let me go back to examples. Okay, so for example, here you start slideshow. If we analyze Les Miserables, so Les Miserables here, you get the link of the input data is actually a text file coming from Project Gutenberg. So you can see it's a long one. And it's represented with 800,000 tokens. Okay, when Gemini ingests this, so this is a text file. It could be an HTML file. It could be any text file, and it can also be a PDF file. So as you can see here, the input is a text file, but when we try to generalize this to legal agreements, you can just provide a PDF file in the input. Okay, so let me go here. Yeah, on the second example. So when we analyze the agreement, if you have a look at the source here, it's a PDF file. So you see, it's an open source. It's a public agreement between two pharmaceutical companies, and this is exactly what Gemini got. I just gave this link to Gemini to tell Gemini, okay, please extract a knowledge graph from this document, from this input data. So it can be a PDF, can be text, can be an image, can be an audio file, can be a video file. So almost everything, almost all the data you deal with. What's interesting with PDF is, so I'm not sure you have some here, it's mainly text. But in a PDF file, what's pretty nice is that you can have images. And so if there was to be, I don't know, a graph here, any picture within the document, within this agreement, Gemini would actually tokenize this image into tokens. And the text here and the image would be at the same level in the input data, just tokens. If it was a video, the video would be tokenized into image tokens and into audio tokens. So this is what I tried to tell you at the beginning of the lab. Gemini is multimodal, so you can use virtually anything: text, PDF files, images, audio, and videos.
Yeah, it'd be a really interesting exercise, the audio, right? Like imagine analyzing a podcast and the conversations
Exactly.
people have and the
Yeah.
arguments and all those kinds of things. We have a question here, which maybe you can touch on, Laurent, which is maybe this is yes or no. Where does the Gemini embedding 2 come in here? Is that part of the process?
So embeddings are not used here, or they are implicitly used because a token represents an information in a semantic space. Okay. So we're not dealing with embeddings here, or Gemini is indirectly. But if I understand your question, so on Google Cloud, and there are also maybe other models doing that, you can take data and transform or index these data into embeddings. So represent something with vectors, with semantic vectors, which are embeddings are semantic vectors. And so typically you do that, you use embeddings when you are building a RAG solution. So if you want to do retrieval augmented generation, if you want to index the documents, so for instance, in this agreement, maybe if you want to have a search on all of your agreements, you can use Gemini directly, or you can, if you do that, I don't know, very frequently, then maybe you can have a rack system and you can build embeddings, and you would have an embedding for example for the first the introduction, maybe for every clause here, you see. And so you build with embeddings, you build a semantic representation in a semantic space of the data you have. So it's a more advanced way of dealing with the raw data of LLMs. But it's more advanced. So you need to build a bigger system. So it's still possible, but here in this proof of concept, as you could see, it's super simple. And it's also you can store the data in the database, but if you just want answers right away, you could build an agent and just get knowledge graphs and explore dynamically. So it's a very fast, easy, and cheap way of building knowledge graphs. But you can also use that with databases or with RAG systems as well. So sorry for people who don't know what RAG is, but typically when you have a chatbot anywhere, and you can have a chat with the chatbot and or an agent, if you have an agent and the agent is linked to some systems to the data of your enterprise, there's more probably a rack system behind it. So whenever you have you have a chat with the agent, it will fetch the right information, just only or some of the right information to be able to provide you with the best answer. So here we just provided all of the documents, and it works because you can go up to 1 million tokens.
So next question is actually related to that point while you're on that topic, Lauren, which is would Gemini be able to combine multiple knowledge graphs that have a few nodes in common into a single graph?
Uh, I've not tried it, but I think so because I could see that Gemini is super good. With as a very high level of understanding. So in this lab, the limitation is that that's actually the challenge: is how far can we go with just one request? So I added some mentions, and there will be an update for the notebook. In a real professional solution, I would not do everything in one request, but I would have a workflow like I would, for instance, put my PDF in cache. It would be into cache because then afterwards I would do several requests. Like I would first extract maybe the entities, have a first step in my workflow to understand to be exhaustive, for instance. If you want to be exhaustive, then LLMs need to focus on just one task. If you really want to extract the hundreds of characters, not only the key characters of a book, for instance, and if you want all the proofs, like you can add lots of additional fields in your data, like you could add an evidence field, like, okay, you tell me that this entity is called like this, but where is it coming from? Give me an evidence. What is the chapter? What is the clause, agreement clause where you got the information? So you can actually have all of this in the entity table. And typically, I would have a first step with everything and as much information as possible, and store this in a database. And to answer your question, in a second step, I would just reuse the entity table, like in the form we saw before, and just provide this to Gemini. So I've tried this; it really works. Um, Let me show you again what we generated here. Yes, here. So yeah, typically you could have a first step that would generate thousands or more of this. So a very long table. And then in a second step, you can just re-inject this, and instead of or and the document again for the relationships. And to fully answer your question, if you have several tables, like if you want to merge graphs, so yeah, I've tried on a small scale. I've tried this; it works as well. What I don't know is how it will deal with IDs. Like you would need to provide new numbers. So I'm pretty sure it would work. I've not tried it, so yeah, but it's really up to your imagination. Gemini was able to generate all of this and uh, like thousands or dozens of thousands of tokens. You can have a look on the big documents. And so, yeah, whatever it's able to generate, it's able to understand. Because, an LLM like Gemini generates tokens on the go. And so every token that is generated is part of the input data until the end of the generation. So yeah, I don't know if I'm clear, but everything that Gemini generates is something that it will 100% understand because it's part of its core generation.
Got it. That makes sense. And I guess related to that as well, a little bit around information and accuracy and reducing token usage. Would using embedding improve accuracy slash reduce token usage?
Um, I don't know. So regarding accuracy, embeddings will not provide more accuracy unless you want to index at the sentence level. It depends on what you want to extract. But if you extract at a very small scale, then you will consume lots of tokens or you will consume lots of data. So yeah, I'm not sure about your question, but if you have a RAG system, then yes, you will save tokens because you will only provide exactly the information you need in your prompt. But this comes with a cost because for a RAG system you need databases, right? And you need the system running on. So to compare cost, it's not easy because you really need to take into account, the total cost of ownership. So you really need to compare, okay, what is the cost of my database? What is the cost of my server running all the time or just sometimes, compared to how many tokens am I going to consume with one Gemini request? And there's no general answer. It depends really on your use case. If you're using a solution 24/7, yeah, most probably at some point it will be more efficient and more and cheaper to have a rack system and to use embeddings. But to get started, yeah, get started just with standard request and see how it behaves. Because eventually you can also have a mixed system. So, for instance, what we've done here could be an agent to build knowledge graphs dynamically. But once it's done, could be stored in a database, could be stored in a rack system, and maybe to optimize everything. If you know that we are going to build similar knowledge graphs about the same data, then yes, maybe it's nice to put your data into a rack system with embeddings, and then do something similar, but just with the data that you need. But it's not that easy. The proof of concept to build knowledge graphs is super easy. A rack system is almost like on a case by case basis, right? So yeah, there's no general answer.
Got it. We'll take one last technical question, which is directly related to what you showed, Laurent, which is on the diagram that you showed at the end with the relationships. Once Gemini produces the data, how is it formatted and how can we extract that data?
Yeah. So the visualization with nodes and relationships, so the visual graph is actually just built from this. Okay, so this is the data. Uh, except that it's long table. So I cannot show. I can only show you this small example, but this is actually what's generated by Gemini. And instead of showing you thousands of lines or hundreds of lines, like a very long text, this is why we have a visualization tool to show the nodes and the edges. But the core data is this one. This is what gets generated. Two tables like this are generated by Gemini.
Great. We have 3 minutes left, so we have. I'll if I can share screen quickly,
Yeah,
Laura.
I'll stop sharing.
Thanks for that. I think so. If anyone has any other questions, I'm sure Lauren's happy to answer them on LinkedIn or anything else. So please reach out to him if you do. There's a few questions around tokens and how you can get access to more content as well. So I just wanted to share this, and I'll leave this on the screen in case you want to scan the code or yeah, just while I talk about it. So we have the Google Developer Program, which you can join. If you search Google Developer Program, it'll come up, or if you're on a mobile device, you can scan this code. And that's a great location for getting technical recommendations, tracking your progress, and you also get hands-on code labs and by the Skills platform. So it's cost-free to join, and you'll get monthly credits to check out some of the Skills platforms as well. You also get an amazing dashboard that looks like this. So it'll show you what you've learned so far. It'll give you other recommendations. It'll show you invites to community events as well that you can join. And it's a great community for learning what's new, what's coming up, and actually getting access to more content, just like Laurent talks to as well. So yeah, that's the Google Developer Program that you can search for, or if you're on a mobile device, you can scan this as well. And then finally, we had a couple of questions on what's next. So next week, same time, same place, we'll be building multimodal apps and custom agents in Java with Guillaume, another one of our developer advocates. There's a link here, and we'll just share the link in the chat as well if you wish to sign up that way. But yeah, same time, same place next week. We want to thank everyone for attending and for all the great questions, and hopefully you learn something that you can apply directly in your workflows, or giving you some new ideas to experiment with as well going forward. So I'll drop the link in the chat for next week's, and we will leave that. Oh, I think Monica's already done it. Beat me to it. Yeah, so we'll leave it there. So thanks everyone for joining, and hopefully see you next time for another Wednesday Build Hour. Thanks, Laurent.
Bye bye, everyone. Thank you.
Bye bye.